Good afternoon, students. Welcome back once again to the mathematics class. In the last lecture, we have completed up to question number 1 to 7. That is exercise 13.5 from probability chapter. So in this section, we are moving towards the question number 8. So the first question is, suppose x has the binomial distribution b of 6, 1 by 2. Then show that x equals to 3 is most likely outcome. So as usually the binomial distribution, what they are saying, b, which is nothing but n comma p. N stands for the number of finite experiments, random experiments, whereas 1 by 2 will be the success. It is b of n comma p, where n is what here? N equals to 6, whereas p is 1 comma 2, right? So hint also has been given. P of x equals to 3 is maximum among all p of xi, that is xi which is equals to 0, 1, 2, 3, so on up to 6. So let's see, x will be the random variable whose binomial distribution is given, that is b of 6 comma 1 by 2. Therefore n equals to 6 and p equals to 1 by 2 already it has been given in the question itself. So the value of q we have to find easily, that is q equals to 1 minus p. 1 minus 1 by 2, it is equals to 1 by 2. So then p of x equals to x. N c x q to the power of n minus x, p to the power of x. So just substitute the values here. N value is 6, n 6 c x, where failure is 1 by 2 and success is also 1 by 2. 3 times x equals to 3, that is 6 c x, which is equals to 1 by 2 6 minus x into 1 by 2 to the power x is the standard form. So now here 6 c x, which is equals to what we'll get, let's see. 6cx, here plus x minus x get cancelled, so only what we get here, 6cx 1 by 2 to the power of 6, right, this term. So it can be seen that x equals to x will be remains if 6cx will be maximum. So then 6c0, what to get, the value is 1, 6c1, 6c5, so the value is what, which is equals to 6, 6c2, 6c4. So let's see once the sum of this 6c0, 6c6, sum of these two is equals to this, then these values is equal. So 6c1 I am taking, then remaining is out of 6, 1 is success, 6c5. So these two are equal. 6c2, then 6c4 will be equal. 6c3, then again 6c3c will be equal, right? So similarly here also 6c2, 6c4, it is 15, 6c3, which is equals to 6c3 means both are 20, 20. So the value of 6c3 is maximum they are saying. Let's see, check once. 6c0 is 1, 6c5 is 6, 6c4 is 15 and 6c3 is 20. 20 is what? It is maximum. Already in hint it has been given. So the value of 6c3 is maximum, therefore x equals to 3. The p of x times success is maximum. So thus x equals to 3 is most likely outcome. So next, moving to question number 9 on multiple choice examination with 3 possible answers for each of 5 questions. On multiple choice examination with 3 possible answers for each of 5 questions, what is the probability that the candidate would get 4 or more correct answers just by guessing? What is the question here? 5 multiple choice questions are there. 3 possible answers for each of the 5 questions they are giving. Then what's the probability that the candidate would get 4 or more correct answer by guessing? So let's see solution for this one. The repeated guessing of correct answers will be whatever Bernoulli style, as we'll know. So x represents the number of correct answers by guessing in the set of 5 multiple choice questions. So the probability of getting the correct answer is 3 possible answers they are given here, that is p equals to what? it is 1 by 3. If P is 1 by 3 means Q is 1 minus P, that is 1 minus 1 by 3 is P by Q. So it is success, it is failure. So clearly X is a binomial distribution where N equals to 5, P equals to 1 by 3 and Q equals to 2 by 3, right? So P of X, where X successor, that is NCX, Q to the power of N minus X, P to the power of X. So 5Cx, N equals to 5, 5Cx, 2 by 3 is a failure, that is to the power 5 minus 6, 1 by 2 to the power of X. So let's see, guessing more than 4 correct answers means X to the power of X is greater than or equals to 4, that is X equals to 4 and 5. So X equals to 4. Out of 5, 4 questions are correct means 4 success we are getting. So 1 success it is 0. This is 1 by 3 to the power of 4. So 5C5, 1 by 3 to the power of 5, 2 by 3 to the power 0 here. 5 successes we are getting. There is no failure. That is 0 failure. So 5C4 is 5, 2 by 3 to the power 0 is 1, 1 by 3 to the power of, so 4 success means it is 1, right? Out of 5. So 2 by 3 into 1 upon 81 plus 5C5 is 1, 1 upon 3 to the power of 5 is 243, 2 by 3 to the power of 0 is 1 only. So 10 by 81 3 is 243, again 1 by 1 243, what we get here 11 by 243 will be the required answer. So next moving to question number 10. A person buys a lottery ticket in 50 lotteries. A person buys a lottery ticket in 50 lotteries, in each of which his chances of winning a prize is 1 upon 100. What is the probability that he will win a prize at least once, exactly once, at least twice? So solution, let's see, already it is given. X represents the number of winning the prizes in 50 lotteries. The trials are nothing but our Bernoulli's trials. So clearly X is a binomial distribution with N equals to 50 and the success they are giving winning prizes 1 upon 100. So Q value is, it is 19 by 100, that is 1 minus P means. So P of X which is equals to NCX, Q to the power of N minus X, P to the power of X, that is 50Cx, 99 by 100, 50 minus X, 1 upon 100 to the power of X. So, winning at least 1. At least 1 means P of X is greater than or equals to 1. At least 1, right? So, here X represent what? Number of winning prizes in 50 lotteries. So 1 by 100 will be the winning chances here, right? So let's see. First question, at least once. Winning at least 1 means X is greater than or equals to 1. Greater than or equals to 1 means it is nothing but 1, 2, 3, so on up to 50. It is X random variable. So probability distribution will be different here for different values up to 100. So these are all equals to what? 1. So you have to find winning at least once means X is greater than or equals to 1. Start from 0, right? So 0, 1 to up to 100 means we have to find all these values from 1 to 50. It will be very lengthy. So simply what we can do here, instead of finding all these values, just we can subtract 1 minus this 0, 1 minus this 0, then what will get directly? The value of 1 to 50. So let's check here. So 1 minus P of X is less than 1 means it is X is 0. So 1 minus 50C0, there is no success. 99 by 100 to the power 50, it is 1 upon 100 to the power 0 it is, right? So 1 minus 50C0 is 1, 99 by 100 to the power 50. So 1 minus 99 by 100 to the power of 50 as solution. So next second one, winning exactly once. X equals to 1 means 50C1, 99 by 49. power 49. It's a failure. 1 is a winning, means 1 by 100 to the power 1. So 50C1 is 50, 1 by 100, 99 by 49. So 51 is a 52 is a 1 by 2, 99 by 100 to the power of 49 is the required answer. So next see, at least twice they are saying. X is greater than or equals to 50. X is greater than or equals to 50 means 0, 1, 2, 3, so on up to 50 is there. So X is greater than or equals to 2 means from this we have to find. So the random variable probability distribution will be different for different values up to 50. So here P is X is greater than or equals to 50 means what we have to do, instead of finding all these values, we have to subtract these two values, 1 minus 0, 1, right? So let's check here. 1 minus P, X is less than 2 means 0 and 1. So 1 minus P, X is less than or equals to 1 also we can write it as. So 1 minus X equals to 0 and X equals to 1. So 1 minus of X equals to 0, X equals to 1, taking probability separately here. So 1 minus 99 by 100, there is no success, minus 1 by 2. For x equals to 1 already we have exactly once we have solution here. So directly we have substituted 1 by 2, 99 by 49. So 1 minus 99 by 49, taking common here from these two terms, inside 99 by 100 plus 1 by 2. So 1 minus 99 by 149, inside it becomes 149 by 100. On simplifying it is what we get, 1 minus 149 by 100 into 99 by 100 to the power 49 is the required answer. So next moving to question number 11. Find the probability of getting 5 exactly twice in 7 throws of dice. What they are asking? Find the probability of getting 5 exactly twice in 7th row of dice. So let's see solution. So the repeated tossing of a die are nothing but our Bernoulli style, already we know. So X represent the number of times of getting 5 in 7th rows of the die. So the probability of getting 5 in a single throw of a die is what? 1 by 6. So Q equals to 1 minus P, it is 1 minus 1 by 6 is 5 by 6. So it is success. So it is failure, right? So clearly X will be the probability distribution with N equals to 7 and P equals to what? 1 by 6 and Q equals to 5 by 6. So P of X equals to X, NCX, Q to the power N minus X, P to the power of X. So N value is 7CX, 5 by 6 to the power of 7X, 1 by 6 to the power of X. Means it is a standard form. So now let's see. 5 exactly twice. It is X equals to 2. 7C2, 5 by 6 to the power 5, 1 by 6 to the power 2. 2 success we are getting, 5 failures. So 7C2 is what? 7 factorial upon 7 minus 2 factorial into 2 factorial. That is nothing but 7, 6, 5 factorial. It is 5 factorial into 2 factorial. 5 get cancelled, 2 ones are 2, 3 it is 21. 5 by 6 to the power of 5, it is 1 by 36. On simplifying, what we'll get? Here 7 by 12, 5 by 6 to the power 5 as it is. It is 21 by 36 is what? 7. 3 7s are 3 12s are 36. Right? So which is nothing but our required answer. So next moving to question number 12. Find the probability of throwing at most 2 sixes in 6 throws of single die. At most 2 sixes in 6 throws of a single die. So let's see solution here. Very easy question. The repeated tossing of a die are Bernoulli's trials. X represent the number of times of getting a 6s in 6 throws of a die. Probability of getting a 6 in a single throw is 1 by 6. 1 minus 1 by p is nothing but 5 by 6. So clearly X has a binomial distribution where n equals to 6, where p equals to 1 by 6, q equals to 5 by 6. So p of x, ncx, q to the power of n minus x, p to the power of x already been in the formula. 6cx, 5 by 6 is a failure, 1 by 6 is success. So here ncx, q to the power of as it is. So at most 2 6s means x is less than or equals to 2. Less than or equals to 2 means it is 0, 1 and 2. 0, 1, 2, 3, 4, 5, 6. X is less than or equals to 2 at most means less than or equals to 2. These three values we have to find here. So 6c 0 success, 5 by 6. So here plus minus get cancelled. Only 6cx, 5 by 6 to the power of 6 we are getting. So 6c 0, 5 by 6 to the power of 6, all are failure. 6c 1, 1 success, 5 failure, 4 success, 2 failure, right? So 6c0 is 1, 5 by 6 to the power of 6, 6c1 is 6, it is 1 by 6, 5 by 6 to the power of 5, plus 6c2 is 15, it is 1 by 36, and it is 5 by 6 to the power of 4. So 5 by 6 to the power of 6, 6 get cancelled, 5 by 6 to the power of 5, and 5 by 12, 3 5s are 15, 3 12s are 12, 36. That is 5 by 6 to the power of 4. By taking 5 by 6 to the power of 4 common, what will get here? 5 by 2 to the power of 6, 4 out means here 1, here also 1, 5 by 12 remains. So now 5 by 6 to the power of 14, inside what will get? 25 by 36, 5 by 6, 5 by 12. By taking LCM is 36, 36 minus 36 is 25, 6, 6 means 6 5s are 30, 12 3s means 3 5s are 15. So 70 upon 36, 5 by 6 to the power of 4. 75 36 is nothing but again 2 35s are 2 18s are, it is 35 by 18, 5 by 6 to the power of 4, right? So finally question number 13. It is known that 10% of certain articles manufactured are defective. Manufactured are defective. What is the probability that in a random sample of 12 such articles, 9 are defective? So what is given here? It is known that 10% of certain articles manufactured are defective. Already it is given defective 10%. What is the probability that in a random sample of 12 such articles, 9 are defective? So let's see. The repeated selection of articles of a random experiment is nothing but our Bernoulli's trial, where X denotes the number of times of selecting defective articles. Here it is a success in a random space of 12 articles. So n equals to 12, p equals to 10% means 10 by 100, it is 1 by 10, it is success. Whereas q 1 minus p, it is 1 minus 1 by 10 is failure, right? So formula already we have 12cx upon 9 by 10 to the power of 12 minus x, 1 by 10 to the power of x. So selecting 9 defective articles out of 12. So 9 successes we are having here. 12c9, so 9 by 10 is 3 is a failure, 9 is a success. So 12c9 is 220, 9 cube by 10 cube, it is 1 by 10 cube. So on simplifying, what we get here? It is 22 into 9 cube, 10 to the power of 11. 110 if we divide by 110, 10 ones are 10 22s are. So only what we remains here, 10 to the power of 11 here. 12 are there, If you divide 1, it becomes 10 to the power of 11. Next, moving to question number 14. In a box containing 100 bulbs, 10 are defective. The probability that out of a sample of 5 bulbs, none is defective. So 4 options has been given: A 10 inverse, B 1 by 2 to the power of 5, C 9 by 10 to the power of 5, D 9 by 10. So let's see. Box containing 100 bulbs, 10 are defective. They are asking probability that out of a sample of 5 bulbs, none is defective. So let's see. X denotes what here? Defective bulbs out of a sample of 5 bulbs. The probability of getting a defective bulb P equals to 10 by 100. It is given already, right? Out of 10 are defective here, out of 100. So 10 by 100 it is 1 by 10 it is success, 9 by 10 it is failure, right? So clearly X is a binomial distribution where n equals to 5, P equals to 1 by 10 and Q equals to 9 by 10. So on substituting the value we have 5cx, that is 5cx, 9 by 10 to the power of 5 minus x, 1 by 10 to the power of x. So none of a bulb is defective means we have to find the probability distribution for x equals to 0. So there is 0 success. 5C0 means 9 by 10 is a failure to the power of 5. 1 by 10 is 0. It is 1 only. So 1, 5C0 is 1. 9 by 10 to the power of 5 is 9 by 10 to the power of 5 is the required answer. That is the correct answer is what? C will be the correct answer. C will be the correct answer. So next, moving to question number 15. The probability that student is not a swimmer is 1 by 5. Then the probability that out of 5 students 4 are swimmers is, they are given 5C4, 4 by 5 to the power of 5, 1 by 5, B 4 by 5 to the power of 4, 1 by 5, C 5C1, 1 by 5, 4 by 5 to the power of 4, D is none of this. The question is probability that student is not a swimmer is 1 by 5. Is not a swimmer, that is nothing but 1 by 5. The probability that out of 5 students 4 are swimmer. Not a swimmer and swimmer. Two possibilities are here. So what we have to take? The text denotes the number of students out of 5 students who are swimmer. Swimmer are success here. So probability students who are not a swimmer is Q, that is 1 by 5. Probability of P 1 minus Q is nothing but P equals to 1 minus Q. It is 1 minus 1 by 5, that is 4 by 5. Q stands for what here? Q is 1 by 5 they are given. So let's see here. What is question exactly? Probability that a student is not a swimmer. Not a swimmer means it is given. It is not a swimmer 1 by 5. What we have to find? Swimmer will be the success. Our question is the probability that out of 5 students 4 are swimmer is, we have to find swimmer. So it is success. Swimmer is success. Q is failure here. P is success, right? So clearly X is a binomial distribution, n equals to 5 and P equals to 4 by 5. So NCX Q to the power of n minus x, P to the power of x, 5CX, 1 by 5 will be what? It's a failure. 5 minus x, 4 by 5 to the power of x will be the success. So 4 students are swimmers. 4 students are swimmers means we have to find 5C4 1 by 5, 4 by 5 to the power of 4. Therefore the correct answer is A. A will be the correct answer. So the question number 15th, A will be the right answer. So with this we will conclude our today's lecture, and as well as the probability chapter and the syllabus also we conclude here only. The whole syllabus we have completed, 12th standard syllabus with this. So if you have any doubts, then you may contact for doubt clarification session. So next we will see in our next program. So till then, take care, stay at home, stay safe. Thank you.